The purpose of this section is to solve all kinds of equations that we have learned how to solve so far, either in this course or in a prerequisite course, and to put them all together in a mixed problem set so you have to figure out, okay, what type of equation is this? What type of technique could I use to get it solved? All right, so here's sort of a rundown of all the different types of equations that we have touched, or that we expect that you already know how to do either from this course or from a previous course. So first is a plain old linear equation. Okay, so a linear equation would be something that looks like say 3x plus 6 equal to 9, right? Most of you hopefully know what to do with that. You'd subtract 6 from both sides, divide both sides by 3 to isolate the variable, right? So that's your goal, to solve it for x. And when x only has an exponent of 1 on it, then the math is pretty easy, right? As long as you're keeping the equation balanced, what you do to one side, you do to the other, you'll get there. Okay, so then another type of equation that you might have encountered is to solve a system of linear equations. So let me give you an example. So if you had two equations, let's say x plus y equal to 1, or 2x minus y equal to 4. I'm making this up. Not even sure if that has a nice solution, but anyway, it's an example of a system of linear equations. So in a prerequisite course, you would have learned how to solve a system like this with two methods, either elimination or substitution. Elimination, if you have variables that would cancel out if you added the equations together, you could do that. Like the example that I put up here has that, where you could add them together and the y's would cancel, and so you'd end up with what would that be, 3x equal to 5, right? And you'd solve for that, and then plug it back into one of the equations to find the y value. The other way you can do this is by substitution. So you can solve, like say the first equation, we could solve for x and then plug in what we know for x into the second equation, which would give us an equation in terms of y, and then we would solve that. So there are a couple different methods that we could use to get that solved. Okay, another kind of equation would be a quadratic equation. We've done a ton of that in this course. You can use factoring, the quadratic formula, or completing the square. The quadratic formula actually comes from completing the square, right? If you have some ax squared plus bx plus c, if you solve that by completing the square, you get the quadratic formula, right? So it's essentially the same thing. So if you don't have a middle term, you can use the square root method, essentially getting the squared term on one side and taking the square root of both sides. That works either if you don't have a middle term, or maybe if you have a binomial squared. That also works well in that scenario. So lots of different methods for solving quadratic equations. I always say, hey, try to factor it first, because that's going to be the fastest thing you can do out of all of them. And then if it doesn't factor, if you find it to be prime, doesn't mean it doesn't have solutions, but you can turn to quadratic formula or completing the square to solve it. Okay, all right, then what else? We have radical equations. Okay, so a radical equation would be something like square root of x plus 7 equal to 11. That would be an example of a radical equation. So you would want to get the square root by itself, do any algebra that you need to do to get that to happen, and then square both sides, or raise both sides to the appropriate power, right? If you have a cubed root, you'd cube both sides, etc. Then also rational equations. We've done a lot of rationals in this class. Multiply both sides by the LCD to clear the fraction and solve the resulting equation. So if you had something like 1 over x plus 1 over x minus 1 equal to 3. I'm just making this up, but something like that, you'd need to multiply both sides by the LCD, which in this case would be x times x minus 1, and then solve the resulting equation that comes out of that. Okay, also absolute value equations, right? So something like absolute value of x plus 1 equal to 7. So make sure the absolute value is isolated on one side of the equation, and then you would make two equations of this, right? So like in this case, you'd have x plus 1 equal to negative 7 and x plus 1 equal to positive 7, because you're not sure if the stuff inside the absolute value signs is positive or negative. All right, and then of course you'd have to solve them both. Okay, so this is kind of an overview. Some of this we've done a ton of in this class. Some of it we sort of expect you to know from your prerequisite material, but that's what we're going to be working with in this section. So now that we've sort of reviewed all of these different types of equations, the goal here, we're going to match the following equations to their type. Okay, so we've just got to be able to look at an equation and notice, oh, that's a rational equation, or oh, that's a radical equation. On the right-hand side here, I've got a whole bunch of equations listed, and on the left-hand side, the type. So we're just going to match these to their type. All right, so let's just start at the top over on the right-hand side. So we've got 3x squared equal to 5x minus 2. I see the x squared term there, and it's pretty obvious to me that that's a quadratic equation. Okay, so I'm going to match the quadratic equation right up here. So this next one, 1 over x plus 3 plus x minus 3 over x squared minus 9 equal to 2. Okay, so I look at that and I see all those variables in a denominator, right? And I know this is one of those ones where I'm going to have to multiply both sides by the LCD and all that jazz. Okay, so that's a rational equation. Okay, rational equation. Okay, now 2 times the absolute value of x plus 7 equal to 10. Okay, so I see the absolute value term there. So that's an absolute value equation. Now, what's next? 8x plus 5 equal to 29 minus 4x. Okay, so sometimes you just got to think about what would you do to solve it. So the variables that are there only have an exponent of 1 on them, right? So that means it's a linear equation, right? And I could subtract 5 from both sides and add 4x to both sides and try to get x on one side, right? So that's just linear, plain up, straight up linear equation. So now I've got this system of two equations, right? X plus y equal to 3 and 2x minus 3y equal to 5, okay? So that's going to be the system of linear equations. I'm going to mark it here. And then the last one, process of elimination, right? 4 times the square root of the quantity x plus 1 plus 12 equal to 20. Okay, so with the square root in it, that's going to be what we call a radical equation, right? Because it's got a radical in it. Okay, and of course the goal of this one would be to get the radical by itself, square both sides, all of that. All right, so all I'm trying to do here is just kind of establish, get the vocabulary going around, what are we looking at? And also, if you notice, I've got a rational equation. I know that I'm supposed to multiply both sides by the LCD, or I know I've got an absolute value equation. I have to get the absolute value by itself and make two equations. Just having some knowledge of, oh, okay, this is what I do when I see this sort of equation. That's what we're after here. Okay, next up, we're going to get some practice mixing them all together and figuring out what to do.